It's basically just been going through limit rules, and the limit rules that exist, you could literally just plug it in, because most functions that we've been looking at are continuous. And when it's continuous, the limit and the function at that value equal the same thing, right? So this one here says theorem, limit of a polynomial function. If p is a polynomial function, then the limit is x approaches c if p of x equals p of c. Because if it's continuous from the left and from the right and at that value, it just equals that value. So for all of these, we literally just have to plug in 3 or -1 or 0. And if they gave it to us from the left or from the right, it wouldn't change it. We'd still just plug it in because it's continuous from the left, from the right, and at that value. So just to prove a point, I'm going to make this one from the left, and I'm going to make this one from the right because it doesn't actually change anything. You still just plug in the value. Because it's polynomial, and it's a continuous function at that value. So for this one, the moment I plug in the number, the limit drops off. So we're going to get 4 times 3 squared minus 3 plus 2. So we get 4 times 9 is 36, minus 3 is 33, plus 2 is 35. So what did we actually find? We found from the left it's approaching 35 on 3, from the right it's approaching 35 at 3. We also know that at 3 it's 35. Slides right through. Now, if it's from the left of -1, if it's a continuous function, which this one is, it doesn't even have to be a continuous function completely. It just needs to be continuous at that value, where this one is continuous everywhere, so we can just plug in the -1. So we're going to get 7 times -1 to the 5, plus 4 times -1 cubed, minus 2 times -1 squared. And so we get 7 times -1 is -7. -1 times 4 is -4. And then we get +1 times -2 is -2. So we get -13. What are you wetting me? So from the left, from the right, anywhere, it doesn't matter, or at that value, it's going to be the same because at -1 it's continuous, right? Now this one's approaching from the right. It's still a polynomial function, so it's going to be continuous from the right at the value or from the left. So we can fill in 0. So we get 10 times 0 to the 6, minus 4 times 0 to the 5, minus 8 times 0 plus 5 is just 5. The rest is all going to cancel off. And I'm posting the homework this week, but like I said, I'm not completely stressed about you doing the homework right now because you can learn it on Wednesday, right? But it will be posted. Okay, for example 10, if I plug in 1, some people will say, well, I have to do stuff to get it to cancel off. Well, actually, let's check it out. If I plug in 1, I get 3 minus 2 plus 1. That's still good. It's not 0. 4 times 1 is 4 plus 5 is 9. I can plug it in. There's no problems here, right? So the first thing I always do is just try and plug it in and see if I get any issues. An issue being like dividing by 0, which I don't have. So I can just plug it in. So I go 3 times 1 cubed minus 2 times 1 plus 1. Also, the denominator is an addition of squares. Does an addition of squares ever cause me any issues? Is there any place where addition of squares can equal 0? No, because the only way I can make this be 0 is if I could do this 4x squared turns to -5. -5 plus 5 is 0. X squared times anything is positive, right? So it's going to end up as positive. So there's no place where that denominator can actually have a problem. So you'll always be able to plug it in when it's an addition of squares. So I'm going to get 3, 4 minus 2 is 2 over 4 plus 5, which is 9. So as I'm approaching 1 from the left, 1 from the right, and 1, I'm going to get 2 9s. Because if I can just plug it in from the left, right, and at that value, it's the same. Okay, this one, if I plug in a 4, is there any issues? No, so I can plug it in. So I get 3 times 4 squared plus 1 over 4 minus 1. 16 times 3 is 48 plus 1 is the root of 49 over 3, which is 7. So we could say from the left of 4, from the right of 4, the limit at 4, all is 7/3, and f of 4 is 7/3. This graph's actually continuous at 4. Now, here's where the problem happens. Finding the limit when your x value is not part of the domain of the function. It means you have like a point discontinuity, or you have an asymptote, or you have a jump discontinuity. Point discontinuity is just a removable discontinuity calculus. So here, if I plug -2 in, -2 squared minus 4 is 4 minus 4, which is, oops, 0, right? So I have a problem. I have a problem because there's going to be there's going to be a problem where if I plug -2 in, it gets me a 0. So we have to do some math first. Thanks, board. So, oops. Still need my limit, because the limit follows along until we plug it in. And we have an equal side running down the left-hand side because each of these limits equal each other. When I factor the top, what multiplies to give me 6 and adds to give me 5? Yeah, x plus 2 and x plus 3. The bottom is the difference of squares, so I get x plus 2 and x minus 2. Now I actually know the x plus 2 is my issue. And the reason why the x plus 2 is my issue is if I fill a -2 in here, -2 plus 2 is 0. 0 times anything is 0, right? So the x minus 2, or x plus 2, sorry, is the issue. And in this case, it's a what? Removable discontinuity, or in calculus, or in math, sorry, point of discontinuity, because it cancels. So we're actually just finding the y value of the point of discontinuity at this point, are we not? When we're finding the limit after we cancel the point of discontinuity off, we're just finding the y value of the point of discontinuity, or in calculus, removable discontinuity. So, it goes limit as x approaches -2. And I don't know why I'm showing this extra step, but I am. At this point, do I have any issues? So I can just do what? Plug it in, finding the y of it. So -2 plus 3 over -2 minus 2, then the limit drops off because I plugged it in, and I get 1 over -4. So this actually equals -1 over 4. What's my problem in B? Same problem. If I plug 5 in, it's going to be an issue. Okay? Now, everyone paying attention on this one? This one has radicals. Do you see it? So I need the x minus 5 to go away. All you do is you multiply by the conjugate of the radicals. So what we're going to do, what the heck does that mean? That means I'm going to go and multiply this by root x plus 5, or plus root 5. Now, guys, I need you to write something above here as a little star, star, star. Because if people distribute wrong, you're going to get stuck. So let's think about it. This here is my issue, right? That x minus 5 is my issue. Do we all agree? Yes. If I can get it to cancel off, my issue is gone. Life is good. I can just substitute in. I get my limit. Yes? So if you go and distribute that in with the square root, are you ever going to get it to go away? No. So what we always do is we distribute the conjugates only, because I need the bottom piece to go away. So in this case, the conjugates happen to be the numerator, correct? So I'm going to FOIL them, I'm going to distribute them. But I'm not going to distribute the bottom, and if you do distribute the bottom, you're now just embedding that x minus 5 in with more stuff, and you're never going to get it to cancel off, and you're going to get stuck. That's what happens on these questions. Either people can get them 100% or 0, because they either distribute that bottom in, and then they're stuck, and they're like, I don't know what to do. It's because you distributed them, and you shouldn't have. Because I need this x minus 5 to cancel off, right? So I need that to stay as an x minus 5. So I'm going to go to the bottom actually first, and I'm going to write x minus 5 multiplied by root x plus root 5. I do not put them together because I need this x minus 5 to get out of my life. Because right now it is my problem. I need it to get out. So I FOIL the top, and I get root x times root x. What happens when you multiply two roots that are the same together?
You get what's under the root sign.
You get what's under the root sign, because root x times root x is root x squared. Squared cancels the root, and I'm left with x. So whenever you multiply two radicals that are the same together, which you're taught grade 10 already, you get just what's underneath. So root x times root x is x. Now why do I multiply by conjugates? We were taught this last year. Because they work out nicely, because they do what? They get rid of the radicals because the middle two terms cancel. Yeah. So the square root of x, x. Square root 5 times square root 5, 5, right? And then you're going to get a positive root 5x and a negative root 5x. So they cancel. The reason why you multiply by the conjugate, which is the same terms, opposite sign in the middle, is because it gets rid of those middle terms, which gets rid of the ones with radicals. So if I multiply the outside to prove a point, I'm going to get root 5 times root x, which is positive root 5x. And then negative root 5 times negative root x is negative root 5x. So this is why we multiply by the conjugate. You were taught it last year. You multiply it by it because these go away, right? Your middle terms go away. And when we multiply by a conjugate with a radical, the square roots cancel. So I get negative root 5 times root 5 is negative 5. What the heck am I left with on the top? X minus 5. And what do I need to go away? X minus 5. You should be getting there, knowing that you need to get there, because the problem that I need out of my life is the x minus 5 out of the denominator. So I'm going to get the limit as x goes to 5 of x minus 5 over x minus 5. What happens when the whole numerator cancels off? I'm left with a 1. Yeah. Yeah, good job, Peter. It was right. Leaving yourself. So, and the reason why you're left with a 1 in the top, oh my gosh, is because these slanted lines are just whats? You're taught this too. These are just 1s. So that's why we're left with a 1 in the top. So we get the limit as x approaches 5. You wouldn't have to show this step, but I am. Of root x plus root 5. So we get 1 over, and the moment I plug in, I can get rid of the limit. Root 5 plus root 5. What's root 5 plus root 5? 2 root 5. If you find that hard to believe, go, what's x plus x? 2x. 2 x's, right? Root 5 plus root 5 is 2 root 5s. We can only put together roots that are the same. And a lot of the time, they'll leave it here. They won't make you rationalize. You could rationalize. It'd be root 5 over 10, right? If I look at C, which of those factors is my problem? Yeah, the x minus 3, because when I plug in a 3, it goes away, right? That's what I need to get out of my life. So when I have radicals and something else, I'm going to multiply by the conjugate every single time. So I'm going to multiply this one by root x plus 1 plus 2. What am I not going to do with the denominator? Distribute. Because I need the x minus 3 to go away. If I distribute it, I'm putting the problem with other things. And I can't get it to go away. Now I know I did good if in the end. Did a good job. Done good. Done well. If the numerator becomes x minus 3, right? Which it will.
I didn't do everything.
So I get x minus 3 in the numerator, and then I get x minus 3, square root x plus 1, plus 2. Cancel, cancel, and left with a 1. And now my issue is gone, so I can plug in. So I get 1 over 3 square root of 3 plus 1 plus 2 in brackets. So I get 1 over 3 times root 3 plus 1 is root 4. Root 4 is 2. 2 plus 2 is
4.
Which is 4. So I get 1 over. These ones that we just did are more like the type of limits that you get where you actually have to fix the problem before you can substitute in. Okay? There will be some that you can substitute in right away. You guys do them worse because you think there must be a problem and you start like moving stuff around. But if you would have just plugged in right away, you would have gotten it. So I'm going to get you guys to do this one. Oh, I love my board so much. Why don't you guys try these two? A and B. Okay, so this one we're going to multiply by x plus 2 plus square root of x plus 2 plus 2, square root of x plus 2 plus 2. Once again, we're still not going to ever distribute the ones that are not conjugates. So I'm going to leave the top. If you follow that rule every single time, you will come out ahead, or at least correct, one or the other. So here we get root x plus 2 times root x plus 2 is x plus 2. And then we get minus 2 root x plus 2 plus 2 root x plus 2 minus 4. And I get the limit as x approaches 2. So I know if it's x approaches 2, x minus 2 is going to be my issue. Square root x plus 2 plus 2. On the bottom I have x minus 2. When the denominator completely cancels off, what's left? Just a 1. Do I need to actually like put the 1 if it's in the denominator? No, only in the numerator. So I get root 2 plus 2 plus 2 is actually
4. 4 plus 2. No.
no. Okay, if I factor the top, what do I get?
X plus 3 squared, x plus 1. Kind of a guess, but...
Is it actually right?
Well,
Yes,
it actually
it
looked
is.
at the factors.
Then it's not a guess.
Valid.
A guess would be like, x plus 7, x minus
Yeah,
plus
maybe actually do
9,
like trace
9er,
factors.
x minus 1er, you know.
Guess would be the case of the Peter, did it cut you?
So these actually just go away with these. You agree? And we're left with,
2. Negative.
yep. You were just testing to see if I knew that. Thank you.
Yeah, Peter's 3 steps.
I was simply test.
So tomorrow we finish the question above. Hunter, eventually you're going to be on the floor. We finish the question above, and we finish the question below. And then on Thursday we do continuity. And then when we come back we do infinity. And then we've done all the limits. We done.